Okay, so before we finish this one, I'm going to pick on Noah Solinger. Noah, it's your time to shine. What is the scalar equation of the plane then going to be? Be brave, you can do it.
3x
Yeah.
minus y plus 2z 4.
Thank you. So that wasn't too hard. Now, on your test, of course, I'm going to make you convert that into parametric and vector. How would I find, like, the parametric or the vector equation of this? What would I do?
That would be -4.
No, because we have -4 plus d, because these two cancel out, -4 plus d, so -4 is going to come across. Okay, so what you would do if you're wondering, which I know you are, is you would pick different points on there. Any points, so x equals 1, y equals 2, z equals 3, and that's going to be one point with the direction vector, give it 3 points, direction vectors and go. We'll do some of that stuff tomorrow. It's okay, but it's possible. Example 3, please put a star and a heart beside this one. Rewrite the equation x, y, z equals 2, -5, comma 1 plus s 2, -3, 0 plus t 1, 1, -1 as a scalar equation of the plane. Okay. Now notice this one is starred. Can someone remind Noah, so I know I've mentioned your name like 100 times, but I can talk about the other Noah too, so pretend that I am last time. What does a star mean? Sorry, question?
That it might be on the test.
There's a good chance that it's going to be on a test. I know people have gotten out of the habit of flipping through their notes, but you should probably do that before a test, Luke, to say what are the big types of questions, and everyone else. Okay. Now we talked about this a little bit at the beginning here. What do we have to do to get a normal? We'll go up to everybody here. Derek, go ahead. Yeah. So what I'm going to do to get n hat. I'm going to call it S cross T. Now, as a reminder, this is, Noah, this is going to be completely new, but for everyone else, you should be okay on this, all right? Vale, I'm going to pick on you since I haven't picked on you yet today. How do you find S cross T?
Do the IJK thing.
Keep going. Keep going, Billy.
Oh, 2 -3, so 2 and 1 -5.
I know this is probably scary to one person in the class. For everyone else, it should not be scary. The bravest person in this class should be Brad. Brad. Why are you guys laughing? Brad is brave. Please don't laugh. Brad. How do you cross? Give me the first line, or the first few lines, please. Go ahead.
3i.
3i. So he did. So what happened for Noah? What he did was I to do a diagonal. I times -3 times -1. So that turns to 3i. Brad, keep going.
Plus 0j.
Plus 0j, and the same thing. J times 0 times 1.
Plus 2k.
Plus 2k. Thank you. That was very brave, so thank you, Brad. Tanner, who's also brave. Can you do the minuses for me, please?
0 and 1. 2 -1 and 1.
Okay, so it's going to be minus 0i plus 2j plus 3k. Can someone confirm that for me?
Yeah.
3i plus 2j plus 5k, which is my direction vector, so n hat Okay, so we've just found out what the direction vector is, which is happy days, okay? Things are good. Brendan, I know you're struggling, so I'll give you a second. Your hair looks like it's straight, but I'm just after here. Okay. Yes, I need a haircut so bad, it's ridiculous. Anyway, I don't want to go there. Yeah, go ahead, Nicole.
Shouldn't that be a negative 3K?
Negative 3 times 1 is negative 3, which is subtracting this way, so that's what it becomes. All right, Brendan, we've solved quite enough. Now that I have my normal, how does that help me find the scalar equation of the plane? Sorry?
Find view thought, consider the scalar equation.
Yeah, and that's sort of what we're going to do. Remember this, I don't know if this is what he said, but I'm going to pretend that he did. These are like just turns your coefficients for x, y, and z, right? Okay, that's what I thought you said. Okay, so it's going to be like 3x plus 2y plus 5z plus d. So we'll get the d for that short, all right? Okay, other than Brendan, who knows the stuff like this, does everyone else feel okay about what just happened then? Now this turns into exactly what we just did in the last question. Okay? Yeah?
So with x, y, z, like with negative 7, would that just be the
Right on. Good. So we're going to sub in. Because we have 2 negative 5.1, right? X and panda, okay? And that's going to give us our d then, all right? So it's going to be 3 times 2 plus 2 times negative 5 plus 5 times 1 plus d equals 0. Luke, you're going to be doing calculator boy for me right now, please. 3 times 2 is 5 times negative, sorry, negative 2. 2 times negative 5 is negative 10, thank you, and 5 times 1 is, that's going to be 11 minus 10, so 1 plus d equals 0, d equals negative 1. Who's my animating of these today? What's my scalar equation of the plane going to be? Can I get a volunteer, please? Let's go.
Okay, so 3x plus 2y plus 5z minus 1 equals 0.
I'll get out of the way, sorry.
So basically, all this is just converting from vector equation to scalar.
That's all today. We haven't actually used the scalar equation for anything yet. We will in the next 2 days quite a bit. Okay, but this is just converting. This one converted vector. You can see how you convert parametric as well too. Parametric is go back to vector and then go forward to scalar. Okay, so. All right, I have one last example, which is good, and then we're going to call it today. Okay, don't share example 4.
Yay!
Stop taking pictures of yourself.
Is this also starting in front or just?
Yes.
Cool.
Example 4 says, find the distance from the point point A, 3, negative 1, 1 to the plane. 4x minus 8y minus z equals negative 1. Okay, this is, we just got to sort of be clear about this, okay? Let's say that my plane is my whiteboard again here. And this is the point I'm going to make. This is 3, 1, negative 1. Actually, let's do it differently right here. Let's try again. Do a different example. So I want to find the distance from a point to a plane, that's what I'm doing for here. So let's pretend that my hand right here is 3, 1, negative 1. What is the closest distance from here to the blackboard? What would it be? Straight line directly from here to here is the closest way I can get there. Does everyone agree with that? Right, so it has to be like this. It's not going to be like this, wouldn't be closest. Right, everyone's got the idea here? What do I call this, this meter stick? What is this called?
The distance.
Good, yes, but something else. We talked about today. What else is it other than the distance? It begins with an N and has a hat over it.
Normal force.
This is the normal, okay, right? So if you find an intersection from a point to a normal, that will be the minimum distance, okay? Everyone get the logic of what we're trying to do here before we continue? Okay. So what's my normal here going to be? Actually, let's go back to Spider-Man here, if we can. Actually, I don't remember where we're at, so now we'll play the rule. We don't have to raise your hand once. Okay? Chris, this is your chance. What is my normal going to be?
So 4, negative 8, negative 1.
I'm hoping that everyone could have gotten that. Jason, how you feeling? Right? That makes sense. The normal is just going to be your x, y, z coefficients. That's what the normal is going to be. All right?
And this is a question.
Yes.
Okay. And then the negative 41, if you just bring it over, it just becomes a scalar equation.
That would be the scalar equation if it would be plus 41 equals 0. Right? Yeah, say that one. Okay. So this is a normal of the plane. We also need any point on the plane. Okay, the reason for that is if I know this is my my distance here, Tanner, okay, I'm not instantly going to be able to get this as the closest point. So what I'm going to do is I'm going to pick any point on the plane. Let's say I was given this and this. So I choose this point where Mr. Newell destroyed my whiteboard. I'm not angry about it, I swear. Okay? I don't want to guess what we're getting at here, though, when I say if I choose this point and this is my distance. How would I find this distance? What would this be?
Sine if you have the.
Sine, yes, good. But we're talking vectors in 3 dimensions, so you can't use sine. Let's try again here. Well, I'm hinting projection, that's what I'm hinting at. Okay? So what we're going to do is, hold on guys, so what we're going to do, stay with me here. What we're going to do is we're going to project this ruler onto the horizontal line here, and that's going to be our distance. Well, if you think what a projection was, for those who haven't been here, right? But if there's your vector and this is the plane, right? If we project it down here, this will be our distance from there. Okay, that's the idea of what we're trying to do there. Okay? So we're doing it in 3 dimensions. We're doing it in 3 dimensions, but that's what we're trying to do here. Well, you're trying to find this distance, though. That's from your distance. Okay?
Yeah.
Okay, so here we go. It is, but you should flip your flipper thinking a little bit. That's what it would be there. Okay? So we have to choose a point on the plane. How would I choose a point on the plane? Okay, I'll take it. Okay? So find the point. Let's choose any x, y, and solve for z is what that's supposed to say. And you can choose any values for x and y that you want. I had a student that liked trucks in like the 70s, so I always use 10-4 because they're 2 digits. I prefer you didn't do that, okay? You can use whatever you want, okay? In this example, so can I get some, what's that? Yeah, you can use 0, 0 if you want to. If you're boring, like not boring, if you're if you're standard like that, that'll still work, okay? Can I get somebody to tell me, Nathan, your 2 favorite numbers in the world?
5 and 5.
5 and 5, that's fine. So Nathan chooses.
Those are huge numbers.
That's okay. So it's going to be 4 times 5 minus 8 times 5 minus z equals negative 41. So it's going to be 20 minus 40 minus z equals negative 41. Negative z equals negative 21. So that equals 21. Can someone confirm that for me? Is that correct? I did that very fast. Is that correct? Somebody please confirm that for me? Please? Confirmed? James, are you kidding, or is that actually confirmed? So why did you say confirmed if it's not confirmed? Ooh. Excuse me.
Yeah, it's
That's
not
confirmed.
wrong line.
That's confirmed, lovely, okay. So we're going to say that the perpendicular distance will be the shortest distance. We'll run low on time. So we will project AX onto N. Okay, so AX is going to be simply enough 5 minus 3, 5 plus 1, and 21 minus 1. Now I'm going to get out of the way. I want to make sure this is clear for people here. Can someone explain to me where I got AX from? What are the 2 points that I used? Chris, you're out already, sorry. Yeah, what are the 2 points I used?
Point A, which is given in the original question, and point X, which we just found.
The nice thing is point X can be anything, not anything, anything that fits the scalar equation, right? So it doesn't have to be that. So AX then equals 2, 6, and 20. So what we're doing then is we're defining the projection of AX onto N. Can someone be brave and give me, Chris, you're out already. You're out.
This though.
No, you're out. Can somebody please give, other than Chris, sorry, I'm sorry that I have to do this to you, Chris.
Okay.
Can somebody please tell me the projection of AX onto N, please? Derek, you're out too. Somebody else be brave. At the back half of the class, nobody raise their hand. Michael, go ahead. Sorry, Max, sorry, I didn't freeze there.
I think it's AX dot N
Yeah?
over N dot N. And
Yeah.
then there's like brackets.
Yeah. So we're just going to, we'll do this one though, so we'll just leave it like that. Okay? Now, then what's going to happen is n times n hat, and what's going to happen is those two guys are going to cancel out. Okay, because we didn't want the projection. All right? So it's just going to end up being AX dot N, the magnitude of AX dot N, all over the magnitude of N. Okay. Sorry guys, I know this is taking a long time, and I'm not going to run out of time. Let's do this fastly. AX dot N should be 2, so we have the point, oops, 2, 6, 20.
So, hold
Too
on.
fast?
So since we're finding magnitude, we can cancel out the x.
No, for this one you can. For this one is the only time you can. Because you don't need a vector's not what you're looking for this case. It's just going to be the projection, so you're going to cancel. We'll do lots of examples like this.
That's because we're finding the magnitude.
Yes, yes,
Not vector.
yes.
Okay.
I have a question.
Yeah, go ahead.
If that's the case, can't you just cancel the end on the top with the end on the bottom?
No. Because they're being dotted. It's not just like it's times, they're being dotted. Sorry, I have to go faster because I'm running a long time. And 9 is 16, 17, 64, 81. 60.
Wait, 16.
Well, it's negative, but it's magnitude, right? So it's positive.
Oh, so it's just gonna.
Yeah. And that was fast and furious. I'm sorry I ran low on time. I will do a question like that for one tomorrow to make it slower. And I'll probably one tonight in the homework. Okay. Homework. Page 459.
Oh, man.
And I will be here this week, Monday, Tuesday, Wednesday, Friday at lunch. So if there's questions on this stuff, come on in. If there is, you had something to go through from the old test and you wanted to go through it, you can do that as well. If you haven't been here in 2 months and you want clarification on what's going to happen this semester for you, come in, okay? Or if you look, something to write tomorrow, did I make a mistake, sorry? Did I make a mistake, or?
No, it's in case it has it.
Oh, it's sorry, because the distance is God, it's like absolute God. Okay, sorry that was so fast. I know you guys are all genius calculus students, so hopefully that was okay. If you realize that